Hello everyone. Today we'll see the concept of shading. In last video we saw the concept of illumination model. So same concept we are going to use in shading algorithm. Now what is meant by shading? Shading is referred as the implementation of illumination model at the pixel or polygon surfaces of the graphics object. Object is having many surfaces. Now for this surface, we'll apply illumination model to find the intensity for the surface. So there are many algorithms for shading. Here we'll see three algorithms. Very first algorithm is constant intensity shading. This is a fast and straightforward method which is used to find the shading of polygon surfaces. It is called constant intensity shading algorithm or flat shading algorithm because entire surface is shaded with the single intensity. So a single intensity is calculated for each polygon of the object. All points over the surface of the polygon are then displayed with the same intensity value. So for a surface, it finds the normal to the surface, then apply any illumination model and then find the intensity for that entire surface. So this type of shading is used when there is required to find the intensity quickly for a surface. So here there is an example of constant intensity shading. Here you can see this object is having many polygon surfaces. If you consider one single surface is having one single shade. If you consider another surface, it is having another shade. Now here you can see these two surfaces, both are in purple, but the intensity value is different. Here it is more darker, whereas it is lighter. But entire surface is having single shade. So all the pixel, all points of that surface is having same shade. So this is what a constant intensity shading. The advantage is it is very fast, simple method, but the disadvantage is that it doesn't create the real effect of the shading. So we have another algorithm which overcome the disadvantage of constant shading algorithm. So another algorithm is Gouraud shading. This algorithm was developed by Gouraud. That's why the name is given to this algorithm. This algorithm gives the shading to a polygon surface by linear interpolation technique. So linear interpolation technique is used to find the intensity for entire surface. So intensity values for each polygon are coordinated with the value of adjacent polygons along the common edges, so that it can eliminate or minimize the discontinuities effect. So this method, it takes the intensity of surrounding polygon surfaces and from that it finds the intensity for particular point or particular pixel. So here basically it is using the linear interpolation to find the intensity at particular pixel position. So further we'll see how this algorithm is working. So there are some steps in this algorithm. So very first step is to determine the average unit normal vector at each polygon vertex. So very first step is to find the normal at vertex. So here you can see this diagram. In this object, it is showing some of the surfaces. Here we can see four surfaces, surface 1, 2, 3 and 4. Again we can see many vertices. We can see here 5 vertices. So very first step is to find the normal at vertex. So here there is vertex, we have considered here vertex V. So first step is to find the normal at vertex. So this normal can be find out by taking the average value of these four normal vectors. So every surface is having normal vector. This first surface is having vector n1, n2, n3, n4. So NV will be calculated by using this formula. It is the formula to calculate the average of 4 vectors. So this step is to find the normal at vertex. Similarly, we can find the normal at all the vertices. After finding the normal at vertices, the next step is to apply an illumination model to each vertex to determine the vertex intensity. Now we have to apply the illumination model at all the vertices so that we can find the intensity at the vertex. So by applying any illumination model, we can find the intensity at vertex 1, vertex 2, vertex 3 or all the vertices. Once we got the intensity value at the vertices, we can find intensity across the edges. So to find the intensity across edges, we are going to use a linear interpolation concept. For example, here we can see, for example, we have calculated the intensity at point 1 and 2. Then we can calculate the intensity across the edge 1, 2. For example, here we are considering point 4, which is a part of the edge. So how we can find the intensity at this point? So this is what the formula. By using this formula, you can find the intensity at point 4. So while calculating this intensity, we are taking intensity value at 1 as well as at 2. So by using these two intensity values, we are calculating the intensity at point 4. Similarly, we can calculate the intensity at point 5 by considering this edge. For example, this vertex is 3. So after getting intensity at vertex 3 and 2, we can find the intensity at 5 by using similar formula. Once we got the intensity at 4 and 5, now we can calculate the intensity at point P, which is lying on the same scan line. So to find the intensity at point P, we can use the intensity value at 4 and 5. So once we have intensity at 4 and 5, we can calculate the intensity at point P, and here now we'll use the X difference. So similarly, we can find intensity of all the interior part of the polygon. So this is what the sequence. Like first we need to find the intensity at vertices. From vertices we need to find the intensity at the edges. Once we got the intensity at the edges, you can find the intensity for interior portion. So same concept can be repeated. So while finding the intensity across edges, we can use the incremental calculation. For example, if we have the intensity at point I, so that is intensity at point I can be found by using the previous formula, or the formula is here again. So once we have got the intensity at point I, then very next pixel intensity can be found by using this formula. So this way we can go from one scan line to another scan line, and you can find the intensity across the edges. Same incremental calculation can be used for interior part. Once you have the intensity for point P, P dash can be calculated from P. So that coherence technique can be used to find the intensity. So this way we can find the shading for the surface for an object by using Gouraud technique. So the advantage of this method is it removes the intensity discontinuity which exists in constant shading model. It can be combined with hidden surface algorithm to fill in the visible polygons along each scan line. Similarly, there are some disadvantages. Gouraud shading has a problem with specular reflection. We cannot obtain the specular reflection effect with this shading algorithm. This algorithm again introduced the anomalies which is known as match bands. So these are some of the advantages and disadvantages of Gouraud shading algorithm. There is one more algorithm which overcome the disadvantage match bands, which is called a Phong shading. So this is third algorithm, Phong shading. This method was developed by Phong. That's why the name is given to this algorithm. And this algorithm, it interpolates the normal vector. So it interpolates the normal vector and then apply the illumination model to each surface point. So it gives a more realistic highlights on the surface and greatly reduce the match band effects. So what are the different steps of this algorithm? So very first, for every surface, it determines the average unit normal vector at each polygon vertex. So very similar to previous algorithm, it finds the normal vector at each vertices. Then after getting the normal vector at each vertices, it uses the interpolation technique, and with the interpolation technique it finds the normal across the edges, and once the normal at edges are found, then normal at interior part is found. So instead of interpolating intensity, it interpolates the normal vector. So here formula is given to interpolate the normal. So once we got the normal vector at all the vertices, then in between normal vector can be calculated by using this formula. So the then it applies an illumination model along the each scan line to calculate the projected pixel intensity for the surface point. Once got the value for normal with the interpolation technique, then it applies the illumination model along the scan line to calculate the pixel intensity. Interpolation of surface normal along a polynomial edge between two vertices is already shown in the diagram. So the main difference between the Phong shading and Gouraud shading is that in Gouraud shading it interpolates the intensity, whereas in Phong shading it interpolates the normal. So it gives a more realistic effect. So what is the advantage of this Phong shading algorithm? It displays more realistic highlights on the surface. It greatly reduces the match band effect and it gives a more accurate results. But the disadvantage of this technique is it takes the more calculations, so it increases the cost of the shading algorithm. So this is what three algorithms of shading.